Hello everybody, this is the notes for Calculus, section 3.4. Again, I'm just putting these up here for your reference later on if you need them or if you're absent or something. So, what we were talking about today is, like it says, definition of the derivative. So, what we have been talking about is an average rate of change, which is just the slope between 2 points, and a instantaneous rate of change, which was the slope between 2 points, but we brought those 2 points really close together. So we're going to kind of change some of the wording on here, and I'll come back to this screen in a second. But what we're looking at here is, looking at this graph, you can see there's a line crossing the graph at 2 points. All right, depending on where we move these points, we're crossing at 2 points. We can kind of slide this around. What we're looking at, because there's 2 points there, if we were to find the slope between those 2 points, that would be our average rate of change. Okay, that's what it meant. It was a slope between 2 points. The instantaneous rate of change is, okay, right now those 2 points are kind of far apart. They're not real close to each other. It doesn't matter where we're at. Those points are kind of far away. So that's an average rate of change. With the instantaneous rate of change, what we did was we brought that distance between those 2 points, okay, looking at where the cursor is, right in this blue box, it says h equals. H was the distance between the x values. What we did was brought those 2 points much closer together. Okay, the closer we can get those 2 points as h approached 0, that became that instantaneous rate of change. Okay, and they're still showing 2 points, but they're really close together. That's the difference here. What we were talking about before, 2 points kind of far apart, average rate of change. When we can get those 2 points to be essentially the same point, what we're talking about is a tangent line. Okay, so if you think back to what we talked about in geometry class, a tangent line and a secant line. A secant line is a line that crosses, we're usually in the context of a circle. So a secant is a line that goes through the circle and intersects at 2 points. Okay, that's this idea here. We got a point there, we got a point there. Okay, there's intersection of, it's crossing the graph at 2 points. That's a secant line. So the average rate of change is the slope of that secant line. The other term was a tangent line. A tangent line to a circle was a line that just touched the circle at 1 point. Okay, so there's only one intersection point. And that's what we have here with this line. We have that red line. It's just touching the graph. It's easier to see when it's down here. It's just touching that graph at that 1 point. Now, we're concentrating on this point here where it's highlighted. Yes, it does come through and intersect, but in this local area around this point, there's just that one intersection. Okay, that's a tangent line. That's what that instantaneous rate of change was. We brought those 2 points that were kind of separate and brought them together, so it was essentially 1 point, that limit as h approached 0. So the instantaneous rate of change, what we're talking about really is just the slope of a tangent line. All right, so just basically what we're talking about here is just kind of changing some of the terminology we're using. The secant line, a line that crosses the graph at 2 distinct points. Your average rate of change, it was the slope of that secant line. So change in y's over change in x's. That's what we got with this. The instantaneous rate of change, that was this equation right here. Okay, the limit as h approached 0. So it was a slope between 2 points, but we brought those 2 points close together with that limit. That was the slope of the instantaneous rate of change. But, like I just said, that's going to be the slope of the tangent line. So, the derivative, all right? This is really what we're trying to build to. So we're going to be talking about this for months and months. But the derivative, it is a function. Okay, so like it says here, the derivative of a function f at x is defined as this. Notice how this is really the same equation that we had before with that instantaneous rate of change. It's just that instead of having an a plus h minus f of a, where that was the instantaneous rate of change at a specific x value a, we're not having that. We got x plus h minus f of x. Okay, the derivative. It is a function. So it's basically the same equation. It's just not, we're not plugging in a number value, we're plugging in x plus h minus f of x. So this notation, that little apostrophe there, f prime is how you read it. That is the derivative. So we can call it f prime of x, we can call it the derivative of function f. And we say with respect to x, and that will have more meaning later on in the year, but just kind of some language that we use. But this is our derivative function. This is how it is defined. It is the slope of 2 points when we're bringing those 2 points so they're super close together. So essentially it's 1 point. That's that tangent line. All right, so the derivative is a function that will give the slope of the tangent line. Now remember, the tangent line is that instantaneous rate of change, or the slope of the tangent line is that instantaneous rate of change at that 1x value. So the derivative, it gives us an equation that will give us the slope of the tangent line at a certain x value. Okay? When we find the derivative, we're not finding a number, we're finding a function that will give us the number, which is the slope of the tangent line. Okay, so difference quotient. These things right here in this box, they're all just different phrases that all mean the same thing. A difference quotient, slope of the secant line, average rate of change. They're just different ways to say those things. It's an average rate of change, it's the slope between 2 points. The derivative, this box in green here, these are all different ways to say the same thing. The derivative, f prime of x, it's the slope of the tangent line. Or it's an equation that gives us the slope of the tangent line. It's an equation that gives us the instantaneous rate of change. All those things mean the same thing. All right, so this is our definition of a derivative. It's a function that gives us the slope of the tangent line. It gives us that instantaneous rate of change at a certain x value. It gives us the function that gives us the instantaneous rate of change. So this is just the first video. This is just the idea of it, where the derivative is that tangent line. It's the slope of the tangent line. The next video, I'm going to go through an example to find the derivative with this example, or with this definition.